Alright, everybody, what is up? So, my name is Nick, and honestly, today there is a bit of a mixed bag, but there's a handful of things I want to get going today. So, I have my autonomous underwater vehicle project, basically a little submarine. And for this submarine, the whole point of it is to get this little guy in this metal tube. It's made out of aluminum. It's going to have a clear dome on it, and then it's going to have a little camera in the dome, which is going to be able to take photos as well as have some pressure and temperature sensors, and also be piloted by an onboard AI using its 2 to 3 motors, depending on how I set it up, its brushless thrusters to do that. And today the whole goal is to get some of the wiring done, learn how to connect all these different connectors. I have bullet connectors. Let's see, yeah. I have bullet connectors. I have these XT90S connectors, so these anti-spark waterproof connectors. And I also have these ring terminals. Each of these all serve a different function, but I want to get it all done. So let's go ahead and go to my laptop camera here, aka the desktop camera. How is it going, everybody? And I have my 10 gauge stranded wire. I should have gotten the tinned wire, the tinned copper wire. That way it's more corrosion resistant. But I forgot about that while I was at the store. So for now, since I am only looking to get the setup for my power bench testing setup, this should be fine because it's not going to go in the water into the actual production vehicle. But yeah, so I'm going to be using my favorite tutor in the world, Chat GPT, because I literally do not know how to do this. So with Chat, let's go. Oh, oops, I don't have all my chats hidden. Oopsies. Here's my AUV project. All right. Now it's saying, see, before when I was planning all this out, I was doing it based off the 10 AWG stranded because, let's see, 10 AWG copper stranded wire ampacity. I didn't even know that was a word. The capacity for amps. Okay, so it is actually only for 30 amps. When I looked at this before, I swore it was for more. Oh, I see. So it is for short bursts that it could go up to like 40. Okay, that may be an issue in the future, but for now, I'm going to say it's okay. Just because I just want to get this practice started. And let's figure out how to basically put wires into a XT90S connection. I think we solder them, but I honestly don't know what to do. I have a soldering kit. I have stuff to solder. I have all of that jazz. I just have never done this before. So let's figure that out. Ooh, I didn't think about if the type of solder I have matters. Oh, this is a fun little, what's this? Okay. There's no way I need like fucking, or I shouldn't guess, sorry. There's no way I need like 3 or 6 gauge wire. That seems overkill because not even the battery has that. I'm going to be using T200 motors. Ampacity chart. So let me see the current draw on these guys. Draw up to 40 amps. Oh, okay. Yeah, wait, where's the... They do actually have a lovely chart here. I believe it's on this thing. Is it under technical details? Amps. Okay. Now it's coming back to me a little bit. So I am probably going to want to go into 8 gauge wire when it comes to actually the production, AUV that I got going on. But since for my test bench, I'll be mostly only doing one thruster at a time, then these 10 gauge copper stranded wires should be fine because I'm only going to be drawing between, like 20 to 30 amps, and that should be plenty for what these wires can handle because it's also only on full throttle. Even in, the environment I'll be in, I'll probably not even do full throttle because I don't think I'll be needing to do any sort of crazy maneuvers. It'll be mostly low to medium power because I also want to conserve my battery life for this thing. So this should be good. There's a chance that the 10 gauge could even make it into the production, so that is not an issue at all. But how? What would the word be? How to attach XT90S connectors to wire? How to solder XT90S connectors.
Okay guys, this video is all about how to solder
That's loud in my ears. I don't know if that's loud in your
XT90
ears.
connectors. I'm going to try and keep it as simple and to the point as I can. Why do we need to solder some XT90 connectors, guys? Well, I'm fitting this cat pack from JJ Customs to my 8S Armor Infraction. Now guys, when it comes to soldering XT90 connectors, do not think that they come apart like an EC5 connector does. So don't be tempted to go and try and hammer these pins out or anything like that, because it will end very badly. As you may gather from the slight laughter, yours truly has made that error. So learn from my mistakes, guys. Anybody wants me to do a video on soldering the EC5 connectors up, then please shout away in the comment section below the video. Before soldering any connectors like these, you need to make sure the wires are well tinned. Now, you can use your soldering iron for doing these, but if you've got any kind of volume of them, I would recommend getting one of these tinning pots on here. Yours for about 20 bucks from your local electronics store or off of Amazon.
Oh, do I have to have them be tinned? I don't want to do that. Have to tin your... Oh, is that a normal... Am I learning something new about soldering? Am I, like, way behind? Oh, I see. I see. Okay. Maybe for today then, we'll pass on the XT90S connectors and the 10 gauge wire, and I'll focus on the bullet connectors. Now, do you need to tin wires for crimping connectors? Okay. Sweet. So for the crimping, I guess I don't need to. And I know I'm just looking at Google AI, but honestly, this is fine. I just want to get a start, and then if something melts or blows up, I'll figure out if it doesn't work. But this is good. So it looks like no bullet connectors, no XT90S connections for today. A bit of a bummer, but that is my bad. I didn't even think about that. Alrighty then. So we will go to the crimping part of it all. And let me go back to chat. Let me actually take this off screen because I want to make sure I'm not... Okay, this is fine. Okay. All right. So let's do new chat. Let's see. Because I was workshopping this here just as an easy way to like house my thoughts. I have my own little project folder in chat, and I want to start. What's the word? Affixing my connectors to my wires for my AUV. I don't have tinned wire, nor a way to tin my wire today, but I want to make progress still. What connections should specifically... Oh, I'm really bummed out the bullet connectors. That's what I really wanted to do today. That's fine. Should I specifically focus on that do not need soldering with tin wire? Please review all our chats, my projects, schematics, and the connections I will need to make between... Ooh, my face is blocking y'all. There we go. Between... So I'll need to make between my basic ESC, my inline... Oh, what's the word? MIDI fuse, I believe? And anything else? MIDI fuse and other connections I am not considering. I have ring terminals, connections, ring connectors for 10 AWG wire, and what size are my tiny ones? I believe this is for 18 gauge, 14, 18. For 14 to 18 AWG wire. This is crazy. So these ones, I don't know if you can tell really how big those are, but these are pretty beefy boys, and these are supposed to be for my 10 AWG, my 10 gauge wire, and then these ones are like half the size, but that's for my, I guess 14 to 18 gauge wire is pretty smaller. I don't know, it just seemed like a big jump. Let's see. No solder, no tin wire by focusing on the high current power path and the ground distribution layout. Blue robotics, inline MIDI fuse, arming switch and plug. See, I can't do the arming switch and plug because I need to use the XT90S connectors for that, and that's not available right now because I don't have the stinking tinned things. Basic ESCs. Oh my, let me get my ESCs out. So here are my electronic speed controllers. I got the blue robotics ones here. You could read that. Yeah. This is the BESC 30-R3, and it's just their basic ESC controller. So let's see what chat's saying. I guess I will need... How much wire do I have? 10 feet? Okay, that's plenty. I don't know if I want to sacrifice some of this just to practice. Yeah, honestly, let's practice. Let's practice on the red, because I think I'll be using a lot more of my black wire for ground than I will be for the red throughout the build here, at least for this section. So, don't mind me just struggling with some wire real quick. I don't want to cut it because it's nice how it keeps it all together. That's really in there. Where's my pick? What's this? I got this cute little O-ring, or this O-ring pick here. It's my like little dental pick, and this should actually work pretty well for these guys as long as the plastic doesn't deform too much on the pick. Oh yeah, this is beautiful. I can go ahead and give you all a better view if you would like. Here you go. I struggle with this on cam. Show my shame live. My Shayla, my shame. Okay, let's focus on this guy in the end. There we go. We got one connection done. Let's go for a 2, a 3, a hump. Okay. And, now that I think about it, I kind of, or no, I have a ton of these. How many ring connectors do I have? I think like in the double digits. I'm pretty sure I bought a specific number of these, but who am I to deny myself the pleasure of experimenting and finding out? All right, and I also got these kind of cheapo wire cutters or wire strippers. I don't exactly know how this one works. Okay. Let's give it a little spin. A little spin. And then a bolt. And then, wheel. Come on, you silly goose. Let's try to show y'all. Well, hey, that worked pretty well. Got these all going. So I stripped some wire, shield your eyes, kids, or get the dollar bills out, you know. All right, and I also wanted to cut some of this. And let me get one of my little connectors out. I'm learning that I should have planned this out a bit better. But hey, we learn by doing in this house. All right. Moment of truth. Will this fit? Okay, it fits. Let me see how it looks when other people do it. Crimping ring terminals. Yeah.
This is the proper way to use crimp connectors. To do this, of course, you're going to need some crimp connectors and preferably a special crimper. Crimpers like these are the best option, but a standard cheap one like this will do. And in a pinch, if it's absolutely necessary, you can make do with any set of pliers to crimp these. But at the very least, I'd recommend having a crimper like this. There are insulated and non-insulated connectors. The insulated are more common, and there is a large array of terminal ends. The wire ends are pretty standard, however, to 3 sizes: red, blue, and yellow. Red is 22 to 16 gauge wire, blue is 16 to 14 gauge wire, and yellow is 12 to 10 gauge wire. But what about the terminals with no insulation? These have no colors. How do you tell what size they are? These terminals will always be stamped with what size wire they're for. For example, this one is stamped 16 to 14 gauge wire. This one again is a little hard to see, but it's stamped 16 to 14 gauge wire. And this is where mistakes are made. These two ring connectors are different sizes, and it's sensible to assume that the small one is for a small wire and the large one for a large wire. This, however, is not the case. Both of these ring connectors are for 16 to 14 gauge wire. And that's where it's important to check the stamps on your connectors to verify the size. Now, crimping insulated and non-insulated wires are a different process. Your tool will usually have a label for insulated and non-insulated crimps. Here on my tool, it says insulated terminals and non-insulated terminals. The side for insulated terminals has a rounded end, and the side for non-insulated has a divot, which pushes a divot into the metal. Crimping insulated terminals is the easier of the two and pretty straightforward with a couple of details. You'll want to strip your wire around 1/4 inch. A good quality strip is one in which no strands are nicked or damaged, the cut is straight and square, and the insulation is not stretched. To achieve this, use the correct cutter size. You can engage the cutters twice to ensure it's cut all the way around. Ease off the pressure on your strippers and pull the insulation off. Ease off the pressure on your strip. Engage the cutters twice to ensure it's cut all the way around. Ease off the pressure on your strippers and pull the insulation off. Pulling the insulation should be easy and smooth. If it is not, your cut size could be too small or too large.
All right, let's retry this one out. I don't think I did a very good job. And hey, that's okay. We are learning. Which parts for... Oh, cut copper only. Okay. Would this one have a cool little measurement like it did? Oh, he did, but I don't have one. All right, I can cut the copper wire with this. So let's cut off the part that I messed up, sadly. It actually does hurt cutting this because I don't want to waste it. Only this cost money, and I don't want to spend the money. Let's try this again. So I don't know if y'all can see this. Will this be backwards? No. So I'm using the 10 on this side, but I'm a little bit confused because why are the 10 and the 8 on the same size? Are they the same size hole? I suppose it has to be. I don't know. So that part's a little strange to me, but I guess it should be fine. So let's get this lined up with the 10. What's better for chat's point of view? Let's do this. All right. 1/4 inch. Do I have a 1/4 inch little measuring guy? This guy doesn't. Does my crimper have a 1/4 inch little guy? It does not. Do I have a ruler? I should have a ruler. I do have a ruler. Hey man, this rules. I agree, I agree, I agree. I agree. All right. Oh my. 1/4 inch is this much? Wow, that is less than I thought. Won't be the first time a guy exaggerated in this life. Okay. I got my inches quartered. Now, let's line this up. I'm using the AWG stranded side for the 10, which is what this is. I did one, and then I'm gonna let it go and then turn it and go for 2 and let it go. And he said it should be slide off pretty easily. This one's not really sliding off, so I see it's not cut very well. I imagine that's in part user error on my end, and then also probably these may not be the best quality ones either, but I don't know. You got to start from somewhere. All right, loosen these up a bit, and then pull. Yeah, por qué? How come these do not work? Why? Why? Because on the first crimp I did, it actually cut one of the little strands, and I don't really want that because I got the size of wire I got for a specific reason. So I don't want to mess with that too much. I'm a bit confuzzled, chat. Like, how is his cut so clean? So fresh and so clean. Is only one of these edges really the cutting edge? See, I'm pretty sure I've damaged some wires now. And that doesn't sound so good. I got it cut now. Are any of the wires straight up removed? I don't think so. Okay. This one's a bit better. All right. So we did the first step. Let's continue with our little tutorial.
Then, at the very least, inspect the first wire to ensure a good quality strip. You can now insert your wire into your wire barrel. Make sure your wires are clear.
let me go ahead and get my heat shrink. Oh, do I have scissors? I don't have scissors. All right, let me get that too. But yeah. Welcome back, chat, to myself. Y'all have been here. Woo, yo. Alrighty. Let's get some heat shrink on this business. I imagine this guy is going to be too small. Let's see. Yep, too small. That's why I got the big size. And this fits beautifully. How much heat shrink do I want?
Close together so they don't fray when you push it in. Carefully place your wire inside. The wire should be visible on the other side, and the wire insulation should be completely covered by the terminal insulation. At the same time, you need to ensure your insulation has not entered into the wire barrel. If your length and size is correct, that shouldn't happen. Now finally, we can crimp. We take our tool and use the correct size, which is blue in this case. Now when placing your crimper, make sure it's not all the way at the edge. Make sure it's slightly behind the edge like this. Now firmly press down to crimp the wire.
Firmly grasp it.
And this is a proper crimp. We should always have visible wire and a bell mouth at the end of the insulation.
Okay, but it's gonna tell me what to do with the little bit of wire sticking out, because that seems like, is that proper? I don't know.
Now this should be crimped on here pretty tight, so don't be afraid to tug on it. Make sure it's on there well. Next, to crimp non-insulated wire, follow all of the previous steps, except when getting ready to crimp, use the non-insulated end of the tool and place the divot on the non-gap end of the barrel. Then press down firmly. And that is a proper crimp. Again, don't be afraid to pull on it. Make sure it's on there well. To me, this seems a bit counterintuitive. I would usually crimp on the gap end so it would fold in and crimp onto the wire, but according to the manufacturer, you're supposed to crimp on the backside. So now we know how to crimp insulated and non-insulated connectors. One tip I have is not to buy a cheap tool like this.
Yeah.
These gaps are incorrect and will not properly crimp your connectors. When first using this tool, I thought I was doing something wrong, but it's the tool itself that has improper gaps. And this is a DIYer's guide. A professional must use a special tool that makes marks when the crimp is properly done and ensures consistency and quality. But this is how you get a proper crimp at home.
Okay. Hey, W to this guy. Let me like that video. James Gatlin, good job, good job, good job. All right. Let me switch back to my little desk cam here. All right, so I got my adhesive insulated heat shrink, or not insulated, my adhesive heat shrink here for my terminals. I'm going to do about, not half an inch, like, how many millimeters would that be for all you smart people? Probably about a centimeter worth. Does that cover my wire and then some? Yeah. Yes, I'll get about maybe a centimeter worth of heat shrink on there. I hope I'm not committing some crazy sin by cutting this like this, but I think it's fine. I would imagine it's fine. I hope it's fine. Alright, I'm just going to slide this down on my wire just because I'm going to hold it there. And I also have this guy. So, chat, I actually have a proper crimper, but I don't know which of these is for which. I believe it actually says on the top here. So I have for insulated terminals, non-insulated terminals, heat shrink terminals, and ferrule terminals. Maybe I can look up the guide here for Klein tools. Let's see. let's look up this part number. Oh, share my screen. All right. Klein Tools 3005 CRDIE 5 CRD. Oh, I want the 306, not the 305. All right. Okay, I got that. Mm. Yeah, but which terminal? I guess let's see. Application, non-insulated terminal crimping. Steel. To know which crimp. What? Attachment? Attachment? To use Klein Tools 3006 CR. All right, let me take this. Go to chat. I am trying to crimp my 10 AWG ring terminals to my 10 AWG wire. Okay. I am doing non-insulated. What is the barrel? Not open air. All right. Non-insulated terminals. Okay, I guess it's literally just that simple in terms of. I thought it might have been like, oh, only do these for ring connection or ring terminals. Do these for bullet terminals. Do these for whatever. But I suppose that's good. All right, let's go back to desk cam here. Ready? We'll get one open, and then you squeeze it. Yeah. And then it opens. Yeah. Sweet. Oh, banana boat. Do I need... Ooh. Please tell me that the Phillips head on this will work. Because I don't want to go get a screwdriver right now. Got my little knockoff Leatherman looking thing here. Had this since I was like, I don't know, 8 years old. Oop, this is not the right size Phillip head. Unless I want to strip this thing. Yeah, ooh, okay. Alright, chat. Hold up. I'll be right back. Alright, we are back. Yeah, so I was able to get this crimped on the 10 gauge. Now I'm looking into the heat shrink part of it all. So I crimped the ring, the uninsulated. Yeah, the uninsulated ring terminal connector onto my copper 10 AWG stranded wire, added some raw adhesive heat shrink before crimping that has not been heated yet. I wasn't sure how much of the ring connector or wire to cover. Can you give me some guidance? All right, let's see what chat says about where to put the heat shrink. All right. So we're here to insulate any exposed metal barrel, add strainer relief, and leave the ring and bolt interface completely clear. Okay. So do not shrink the ring itself, as well as 1 to 2 millimeters of metal on the neck. All right. Okay. Should do this. Should be fine. Should be fine. My heat shrink might be... No, it's a pretty good size. All right. Ooh, so the heat shrink might be a little small, actually, apparently. But it's okay. This is just for tests and giggles. All right. Can this fit over the ring if I need to? No. This is the decision I have made, I guess. The guides I looked at had 2 meters of wire out of the crimp barrel on the ring side. Should my heat shrink cover that? Alrighty then. This is good. This is good. Alright. This should be fine. Okay. Let's go about there. Yeah, so I definitely wanted to have cut the heat shrink longer. That's a good note for next time. So I don't think there's any rectifying this at this point. Alrighty, chat. And just to show you what I mean in terms of having it covered. So you see here how it's just like, it's just barely covering that barrel. And then actually on this side, it's like just barely at the end where it's cut. So it's barely covering that portion. And that's, I thought we would have wanted, but it does make sense that we want some of that strain relief on the wire itself. So lesson for next time. But don't mind if we just slide up real quick. All right. Well, it does its magic. Ooh, it's shrinking and it's heating. Okay. Now let's go on this side. It's doing its magic. It's doing its magic. Okay, yeah, so major lessons learned. Because there's still a little bit of the copper wire exposed on that end. It's not all the way covering it. And also on this back end, it's just barely at the point here where it's fully covering that wire. And ideally I would use a heat gun, but I just don't have one, nor do I want to shell out the money for one at this point. I feel like I'm heating up a crack spoon. Y'all got some crack? I think that's as shrunk as this heat shrink's gonna get. But here's the final result. Not too bad for a first showing. It's not the absolute first time I've touched heat shrink, but it is the first time in this context I've done all this together. Now my question is, do I plan to use this little guy? Because what it's ultimately for is I have these MIDI fuse holders, and I'll show you how those are going to work out. But essentially, the fuse holders are meant to hold these fuses here. That's what they look like. This is for 100 amps, I believe. I have to double check that. Yeah, 100 amps, hence the 100. And what you do is you take off the nuts. So you neuter your holder. And then I hope these are the right size. They should be, yeah. And then I forget if you put fuse or this ring terminal first, but let's just for the sake of example, let's say you put the fuse in there first. I am not going to take it out at the moment just because it's over there and I don't want to. So you say you put your fuse on first. It's all locked in there. And then you put on the ring terminal. And then you toss on your nut. Once you get your nut on there, you fasten it down. Which actually doesn't fasten down. Huh. Actually, let me go ahead and get that fuse because I'm a little concerned about these things just kind of like being all up on there. Maybe that's so you could fit multiple ring terminals on there. But then my question becomes, what if you only have one ring terminal? I assume that's where you get washers or something that come into play. But in this case, I have the 80 amp one. Toss it on there. I'm going to toss on my ring. And then I look to clamp this down. And these lugs, not these lugs, these nuts have a stop. So I'll definitely need to get washers or just have enough ring terminals on there to clamp that down. And then where are the tops? All right. And then once I get in there, hey, maybe the tops will clamp them down. No, not really. Just so you don't get your fingies all shocked. You put the top on here. Ooh, I hope it's not like the XT90S connectors. Those things, just to try them out, I connected them together, and that was a process to get off. All right. There we go. Okay. So this is what it looks like when it's there. It has the wire feeding in. It's a bit of exposed metal, but I suppose I could have done better in my purchasing decision, but this is fine. Yeah, that's how that all looks. So I'm pretty happy with that. All right, now ultimately, I need to figure out what is going to have ring terminals. I had this mapped out a week or two ago when I was working on this last time, but it's been a little bit since I really thought about it in depth. Let me thonk on this for a second. Because we have, see, the tinning wire thing is actually a really big setback for the day because I did not even really consider that. And that is essentially what I was planning my entire day around, was that process. I know the Arduino stuff, or not the Arduino stuff, the logic processor thing. The brains of the operation is going to need ring connectors for some of the things I'm connecting it to, especially for ground. All right, you know what? Let's talk this out with chat. GPT, chat GPT. Oh, let me get rid of my crimper too. Not gonna be crimping for a second. All the crimps in the club, yeah, I'll drop it like it's hot. Here we go. Shout out to the crimps. There we go. You can tell I'm doing something because there is noise off screen. Sweet. Well, got it, crimp. Okay. Oh yeah, talking to chat. So I guess let's just talk about my power distribution in general and kind of talk it through and see if our Lord and Savior chat has anything to add to the subject. All right. For my power distribution, this is what I had in my head so far. Ooh, let me double check also. Let me get my ESC. Okay. I forget. Oh no, okay. I think this is what I want. All right, for the ESC, I don't know if you could. I guess I'll take it out. No, I don't want to take it out. It's all vacuum sealed. Let me switch to laptop cam just so I could explain this. Because I believe this is the case. I could have it backwards, but it's essentially this is the situation. So you have these red wires and black wires here coming out of the ESC. And then on this side, you have the blue and the white wire, or the blue, white, and the green wires. Oh, that makes it simple. Okay, yeah. So on the ESC, you have red wire and a black wire on one side. That is where the power from, in this case, my battery, is coming into the ESC for the electronic speed controller for my motors. And then on the opposite side, that is where you have your, what's this? Blue wire, your green wire, and then your white wire. So 2 of those wires there are for the power to the actual thrusters themselves, and the other wire, I believe, is a signal wire that helps tell the motors what to actually do with their, like in terms of how much thrust to go through, forward or backwards. Actually, the forward or backwards might be on my end, but definitely to see how much power essentially to put through and use for the motor. So in this case, I am connecting my ESC, my speed controllers, to my battery, and that chain has a couple steps to it. So going back to chat here. So for my power distribution, that's what I had in my head so far. I have my blue robotics battery. Then the battery connects to the fuse. Oh, so I could set up, oh no, I don't know. Connects to the fuse, to the inline MIDI fuse. The connector between the battery wires and the fuse wires is a XT90S connector. And then once we have that connector, I will be, and there is the fuse that is connected to wire using crimped ring terminals. Then we go to another XT90S connector for the arming plug for the setup for the arming plug. Then we connect to the ESCs, the Blue Robotics, just so it can't give me an excuse for not knowing what it is. The Blue Robotics, do I have it here still? No. The Blue Robotics B ESC 30-R3 basic RSC. The ESC will connect to the thrusters via bullet connectors. I write so far. Okay, and this is why not having the tinned wire and the solder is such an issue or roadblock for the moment, is because almost all the connections I need for the main power supply is actually for the XT90S. That's like almost all the connectors are the ST90S or the bullet connectors. I really only need ring terminals when it comes to actually building out like a ground bar and a power bar for all my different connections. So that's kind of a big headache. Let's see what chat says. So basically the right logic, first fuse, and then the way to arm and disarm, and then the ESC, two big refinements. Put the fuse as close to the battery as physically possible. Battery, and yes, fuse, this works. Creates a risk. The wire and the connector segment between the battery and the fuse is unfused. If that section ever shorts, okay. All right, see the issue with this though is the Blue Robotics battery is already connected to an XT90S connector. So it's like, of course there has to be a freaking connector. All right, we'll argue a chat with that in a second, because I really don't want to cut into the battery wires directly. That just sounds like a bad plan for someone who's not very well versed in this sort of thing. All right, so this is fine. Okay. So the battery to an XT90S, to the fuse, to the XT90S, to the ESC, this works, but it creates a risk. The wire and the connector segment between the battery and the fuse is unfused. If that section ever shorts, if there's damaged insulation, pinched cable, connector failure, the fuse can't protect it. The better practice is battery, very short lead, MIDI fuse, the arming plug, and the ESC. You want the battery to be removable. Put a connector at the battery. Okay, that's literally what I'm doing. So chat, I guess, just doesn't know, which is fair, I guess. One arming/disconnect connector is usually enough. If you have XT90S near the battery and XT90S for the arming plug, that's two high current connectors in series, not automatically wrong, just more voltage drop, heat points, failure points. Okay, so maybe I don't need the arming plug at all if the battery already has one. Okay, my nose itches. All right. So most builds choose either one connector as the arming disconnect or a battery connector, separate arming device, but only if there's a real reason. ESC plus thruster bullets, that's correct. Bullet size, yeah, I'll do that. Good strain relief, It's inside a dry tube for these connectors, I believe. I have to double check on that. But I believe this is all going to be fine. But you need negative side distribution. Everything above is positive path. But you also need battery, common negative point ESC, and any buck converters. Oh, did I ever get my buck converter? I did not. That's still in the mail, I guess. All right. Don't just stack a bunch of rings on the battery terminal if you can avoid it. A small bus/bar stud. Did I thought I bought that, but I guess it hasn't come through yet. Okay. Also need to get that. Quick sandy wrap. All right. What am I going to be connecting to ring terminals of these? And I want to make progress today, but I forget where I was going to put them. Wire stud bolt bus bar, yeah. So obviously the MIDI fuser, I'm going to be doing that. That's what the practice today was for. Honestly, where'd my wire go? Let's just cut that. I'll cut that in a second so I can get on cam for y'all. Positive distribution point after the arming plug. If you're feeding more than one thing, ESC plus a buck converter later, you want a stud. Okay. That's good to know. So I want multiple bus bars. I swore I bought them already, but I guess I have to double check on that. Arming out plus bus, later converter. Today you crimp arming out to bus, ESCs. Negative distribution point. Are not for. Yeah. My battery is connected with a. Please look up again the Blue Robotics battery I have. You know what it is. We have talked about it. The battery comes pre-installed with an XT90 with an XT90S connector. Huh. It's not looking too good today, chat, in terms of the progress I can make. Let me see if I can remember anything else I need. Ooh, no, I don't have the freaking I2C converter thing. Ooh, getting a phone call. Howdy, howdy. Streaming. Yeah.